CPCTC, said she. Find out what it means to me. CPCTC, said she. After two triangles congruent, you see corresponding, 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 corresponding parts of congruent triangles are congruent. Corresponding, 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 corresponding parts of congruent triangles are congruent.
Well, hello there, everyone. Welcome to our last lesson in Chapter 5 for our Big Ideas Geometry. Here we are with using congruent triangles. And we're going to see how that video at the beginning, that little song that we saw there with the CPCTC comes into play as we're going to be doing this lesson. We're definitely going to be using CPCTC to be able to show that corresponding parts of congruent triangles are congruent. So if we were going to try to figure out, some congruent parts there, we got to use always that CPCTC. So before we get into this, let's go ahead and look at our cartoon. Here we are. So a turtle's outside of his shell. Says, "Dang, locked my keys in the house." Can't get back into his shell. All right, moving into our note-taking here, and the only thing to actually write down on the note-taking is that CPCTC, as we saw in that little video. So it says corresponding parts, so it gives you that first part. I just continued on from there. Of congruent triangles are congruent, and you can abbreviate that right below there as CPCTC. So instead of writing this down every single time, we can always just abbreviate it as CPCTC. So it's C is every other letter, but then we have a P and a T. So C, P, C, T, and then C again. Now that's on page 155. That's where you want to write that down. All right, so let's check out this problem with the hang glider. You don't need to write this one down. Let's just go and watch this. This is actually in the book. It just says, explain how you can use the given information to prove that the hang glider parts are congruent. And so we're given some information here. We're given that angle 1 is congruent to angle 2. That's actually on the outside here, not these inside ones, but the outside ones. And these two angles are congruent with RTQ. So RT is here in the middle, and Q. So this angle here is congruent to RTS. That's this other angle here. So we know inside these two angles are congruent, and on the outside these two are congruent. So the first thing we want to do is just kind of draw this diagram down with the triangles like this, and we'll mark the given information. So we're given that these angles here, 1 and 2, are congruent on the outside, and these two on the inside here are congruent. And once we've done that, then we can kind of mark some deduced information. So if we know that angle 1 here and 2 are congruent to each other, and these are both supplementary, so these have supplementary angles or a linear pair, which are supplementary here with this line, basically from R to Q, we know that this angle and then this angle here are going to be also going to be congruent. That's what we can say. So the marked information that you can deduce, then marked information that you can deduce. That's what we're doing here on the next one. So we can now deduce that because RQT, so RQT and RST, that's these ones here inside, are supplementary to congruent angles, so that means they're congruent to each other. And so we can say that now these here in blue are congruent to each other. We can also say that RT is congruent to itself because of the reflexive property, so we have a side there. And from that point we can now say angle, and side, that's the AAS congruence theorem. So now we can conclude that these two triangles are congruent. And what we're trying to prove here is that QT is congruent to ST. So QT here is congruent to ST here. And so that would be true now at this point. Once we've proved the two triangles congruent, we can now say that because corresponding parts of congruent triangles are congruent. That's the CPCTC. So therefore QT has got to be congruent to ST. So all the other corresponding parts, in fact, RQ and RS are going to be congruent to each other. All these other angles inside here are going to be congruent to each other because of CPCTC. Okay, on page 156, our extra practice, we have 1 through 3. It just says explain how to prove that the statement is true. And the statement here on number 1 is that UV is congruent to XV. So that would be right here. UV, this segment here, is congruent to this segment of XV over here. So in order to be able to prove that these corresponding parts here are congruent, as they are corresponding to each other, we would need to prove the two triangles are congruent first. So if we can prove the two triangles congruent, then we can use CPC/TC to prove and show that those are congruent. So first, what we would need still to prove this, what we have marked on here is we have an angle and a side so far. So it's an A and an S. What else could we deduce? So the deduced information can be right here with vertical angles. These create vertical angles, and vertical angles are always congruent. So we can see that those are going to be congruent. And we're trying to figure out which one of the ways, the 5 ways, remember these are 5 ways here of proving triangle congruence. And we're trying to build at this point, once we get those vertical angles there, shown that those are congruent, we have an A, an angle, a side, and an angle, ASA, the sides in between. So ASA, the one here at the top here, ASA. And the only one that's different there, which is a little bit different, I circled that one, the HL theorem. That again is for hypotenuse and leg, which is for right triangles only. Everything else would be for any other triangle. So now we can now say this, we can deduce this. We would first want to say that these two angles here, UVT is congruent to XVW. We want to first say that to show that those two angles are congruent, and the reason why is because they are by vertical angles. They're congruent by vertical angles. That's the first thing then to write down. Then we can now say that the two triangles are congruent. So we now would want triangle UVT is congruent to triangle XVW. Again, you're just making a congruent statement here. So just make sure everything is matching up. That, X, so if I'm starting with U, I'm going to start with X, and then I'm going to go to V next. V is for both of them in the middle, and then T is the last one of each one. So just make sure your congruent statement is correct. And they're congruent by the ASA congruence theorem, so right there. And now that I've shown that those two triangles are congruent, I can now say this, that UV is congruent to XV, and the reason why is because CPCTC, corresponding parts of congruent triangles, are congruent. So once we show that the true triangles are congruent, then all the corresponding parts of those two triangles are also going to be congruent. Number 2, so we have TS is congruent to VR. So TS down here is congruent to VR up here. So in this one, we want to figure out that we do have a right triangle. So I'm thinking about the HL on this one. Hypotenuse, we have the hypotenuse here. We have the hypotenuse on this one, and a leg for the second one. So we do have hypotenuse leg. So there's nothing else in addition that I need to say or show. I can just go straight to saying that these two triangles are congruent by the hypotenuse leg, by the HL. And so I'll write that down first, that the two triangles, triangle TSR is congruent to triangle VRU. And again, we want to just make sure we're going off the same thing here. So T is the right angle one here. So I got to start with the right one on this one, V. And then I'm going to go up to this angle here, R. That would correspond to U. So let's see, V. Actually, I did that wrong, didn't I? That should have been the other way around. I think I did that because I thought that was a middle one. So it should be TSR. So TSR. And then the next one should be VRU. Yeah, that was right. Yeah, I did that right. TSR, VRU. I did that correctly. I'm not sure what I was thinking. But yeah, TSR is correct. So T and S is the next one. That's right, I went up to R first. So T is an S, and then R. And so on this one, we're going to go VR and then U. VR is this one, and then U is that kind of smallest angle there. And now we can say that those two triangles are congruent, and we'll say it by the HL. That's hypotenuse and leg. And then because those two triangles are congruent, we can now say this, TS is congruent to VR. And the reason why is because of CPCTC. So always the end result is going to always be by CPCTC. Once you've shown the two triangles congruent, then we can say the corresponding parts they're talking about here are congruent because of CPCTC. Okay, on number 3, for this one, we're seeing angles here. They want to show angles congruent. JLK, so JLK on this one, that's this angle, is congruent to MLN, that's this angle here. And so what do we have so far on these triangles? Well, we have two sides and an angle, and it is an included angle. So looking up here, we have two sides and an included angle for SAS. We can use SAS on this one. So side, angle, and side again for each one. So there's no other additional information I need on this one. Number 1, I did need a little bit of additional information with vertical angles right there, so I had to say that first before I could just go straight to saying that the two triangles were congruent. This one I can just go straight to saying these two triangles are congruent, so I'll say that, and triangle JLK is congruent to triangle MLN. I'm just using the same statement here, the same letters, because I know that those are correct. And that's the reason why, and you always got to state which reason here. Angle or side, angle, side, SAS for this one, so by SAS. And now we can say this. We can say these two angles are congruent, and the reason again is the same reason always at the end, CPCTC. Corresponding parts of congruent triangles are congruent. Alright, so here's our joke of the day. Why did Cinderella get kicked off the soccer team? Well, because she ran away from the ball. That's not good in soccer. You're supposed to run towards the ball. Okay, so continuing on with our extra practice, 4 and 5, I think this is at the bottom, and then 5 is at the top. But we're trying to write a plan to prove that angle 1 is congruent to angle 2. So in number 4, angle 1 is down here. That's this angle right here, and angle 2 is up here. Trying to prove that these two are congruent. So we actually have quite a few triangles in this figure. You can see the 4 triangles that are just inside here. You have these two here, which looks similar or maybe the same, and these two on the sides here. But then you also have these big ones as well, and it shows you a right angle up here, so it definitely is a rectangle. But you have these big triangles this way here, and another one this way here. So there could be more than one way to get to the answer of proving 1 is congruent to 2. It's not just only one thing you can say, but you can probably say a couple ways. I'm going to show you a couple ways here. So the first thing I'm noticing on the diagram, we have marked so far that this angle here is congruent to up here, and this side here from G to J is congruent to I to J. So what we could do, because we do have vertical angles right here, we have congruent angles here in the middle. These are congruent. These are also congruent here, but the ones that we want to really notice are these two on the side. They're congruent to each other. And so now we can now say that these two triangles here on the side, these two like wings of here, are congruent with angle, side, angle. So because of the ASA congruence theorem, we can then say these two triangles are congruent. So let's go and write a statement that says that. Triangle FGJ, so FGJ, that's this triangle here, is congruent to HIJ, HIJ right there. And the reason why is because of by the ASA, angle, side, angle. And so now that we have that, we then could say that this angle here, 1 and 2, are a part of these triangles. So we can now say that angle 1 is congruent to angle 2 because of the CPCTC. Corresponding parts of congruent triangles are congruent. So 1 and 2 are one of the corresponding parts of these triangles that we just showed are congruent, and so we can say that. So that's one way, and I think that's probably the shortest way. Now the way they actually showed in the answer on the book is a little different, and I'll show that to you here. They first started off by saying use angle, angle, side congruence theorem, because that's all marked off for these big triangles. So if you have this big right triangle here, this big right triangle down here, you have angle, angle, and then this side here is all the way across, which is a shared side. So that would be congruent to itself. So we can assume that we have angle, angle, side. So you can use AAS congruence theorem to show that those two triangles, these big ones here, FGI and HIG, are congruent. And so because of that, we can then say that these two sides here along this way are congruent. FG is congruent to HI because of corresponding parts congruent to congruent, CP, I just wrote it there. So that means that these two here are congruent to each other. So because of that now, we can now say that these two triangles are congruent. Eventually you see you have to get these two triangles congruent. They're just doing it a different way than I did it with ASA. I think I probably did the shortcut version, and they're going around a little bit longer. So now you have, on just these two triangles here, we now have a side, an angle, and a side. They actually wrote this wrong. This is a typo. They put ASA, but it really should be SAS. That's what they can now use. So I crossed that out to show that those two triangles, FGJ and HIG, that's the ones we have now here. We proved it with ASA. We now can prove it here with an SAS, with the information we were given. And so now at that point we can then say the same thing. One is congruent to 2 because of the CP-CTC. So again, you just have to copy this part down really, because that's the short version, I think, to get to this with vertical angles. We know these are vertical angles, so those are congruent. Number 5, let's go up to 5. 1 and 2 are down here on these triangles. So eventually we need to show that these two triangles here are congruent. But we do have, again, other triangles. We have the ones up on top. We have the big ones as well. And so the big ones are probably the ones we want to actually talk about, because we have a side here and a side here on these big ones and a shared side along here. So that's SSS. We have all three sides on the big one. So we can quickly just say that ABC is congruent to DADC. That's the big ones here. ABC and ADC are congruent because of SSS. That's because we have the AC is congruent to itself with a reflexive property. And so now what we can do is we can say that any corresponding parts of those triangles, which this angle right here, down here, is one of the angles that's on this triangle that we need, that this angle is congruent here. So these two angles are congruent right there, and we can name those angles here as angle ACB, so ACB and ACD. Those are congruent because of CP-CTC. Corresponding parts, congruent triangles are congruent. So see how we keep using this same thing on every single problem here in this lesson. So now that we know, okay, these two are congruent and we're on this triangle, we have a side, we have an angle. We also can go off of here that CE is congruent to itself. So now we can say that these two triangles here down below are congruent where the 1 and the 2 are. They're congruent because of side, angle, and side again here. So we now make a little congruent statement for those two triangles. BCE and DCE are congruent, and that's because of SAS, side, angle, side. And now we can say 1 is congruent to 2. So now 1 is congruent to 2, and that's because of CP-CTC. And here is what they said. So they pretty much did, I think, what I did here. They started with the SSS to show that those two big triangles were congruent, and then they stated that those two were congruent because of corresponding parts, and then they used SAS again exactly. So they did it exactly the way I did it here. There was no other way to do this one. All right, let's move on to number 6. Okay, so problem number 6 is a kind of a proof of a construction. So we can see our construction here in the proof here. It says write a proof to verify that the construction is valid. So here's our diagram on this construction, and here is that we're doing this construction right here, that ray bisects an angle. We're trying to show and prove that a ray bisects an angle on this proof, that this is valid, that this ray right here going through, ray AD, bisects angle BAC. And so it says the plan for proofs show that triangle ABD is congruent to triangle ACD. And so we have some given information from the diagram. So the diagram shows us that AB is congruent to AC. Those two are congruent, and it also shows us that BD is congruent to CD. That's what we see in our statement number 1. So for number 1, you're going to write out that's our given. So that's the given for over here. The reason is it's given on the diagram. And so that's what we can mark off even on here, that these two are congruent. And we can draw a line. You can draw a line here and show those two are congruent. And that creates the two triangles that we want to see here. And that's what it's saying here. ABD, this triangle ABD is congruent to ACD down here. So we want to show these two triangles are congruent by SSS. And we can do that now because obviously AD is congruent to itself because of reflexive property. So that's going to be all right here. AD is congruent to AD. And the reason is because of reflexive property. That's number 2. So then we can see that. Oops, I was going to put that there, those 3 marks there. And now we see, oops, there we go. There we go. All right, so then we want to, after that, use corresponding parts of congruent triangles to show that other things are congruent. So it says use corresponding parts of congruent triangles to show that angle BAD is congruent to angle CAD. So BAD, this angle, and CAD, that's going to be congruent angles, which would show that it bisects it. So now we can say that those two triangles are congruent with the SSS. That's what we're saying now because we have side, side, side on both of them. And now we can say that these two angles are congruent, and the reason is because of CPCTC. You can just abbreviate this and just write CPCTC for number 4, and that's it. All right, that concludes our lesson here for 5-7, and you want to go on to the assignment, and then we'll be ready for a quiz. All right, I'll see you on the next chapter.